Good evening, everyone. We are going to talk about today about your paper of solutions and principles of practical chemistry. In this case of today's paper, we are going to focus on question by question approach. If you check the first question that has been asked us, which of the following pair of aqueous solution can be expected to be isotonic at the same temperature? Here, the same temperature clearly indicates that in our formula, that is pi equals to, in the formula of pi equals to ICRT, the CRT value will be same. What value will be same? The CRT value will be same. The only value that is going to change or that is going to alter is nothing but the I value. That is nothing but the I value. So guys, is as the I value is changing, what we need to do is we need to focus on each and every component that is having giving us a different I value. For example, in case of CaNO3 whole twice and in case of Na2SO4, if you focus, the I value is going to come as how much? The I value is going to come 3 here, and here also the I value is how much? I value is 3 here. So as both of them is going to give me the I value to be 3, we can tell that both of them are isotonic in nature. Why? Because urea will be giving me I value 1, NaCl I value 2, NaCl I value 2, Na2SO4 I value 3. And the last one, glucose I value 1 and MgCl2 I value 3. So the best one that is going to match it is option C, that is CaNO3 whole twice and 1 molar Na2SO4. Let's go for the next thing. We are going to talk about the among the following solutions, the correct order of decreasing boiling point. Again, here one thing comes into fact, that is the I value. I value of glucose is how much? I value of glucose is 1, whereas the I value of NaCl, CaCl2 and KCl are different. The I value of NaCl is 2, the I value of CaCl2 is 3, and the I value of KCl is 2. So guys, we need to find out the exact molarity of these values accordance with their I values. So how to solve it? If you check the solution, we need to do the multiplication of the I value with the molarity, that is glucose, it is 0.05 mole. Glucose, it is how much? Glucose, it is 0.05 molar. KCl, it is 0.04 molar going to be, right? And CaCl2 is going to be 0.03 molar. Finally, NaCl is going to be 0.02 molar. So due to this reason, we can easily find out that glucose shows the highest elevation, whereas the other ones shows followed. Other ones follows it. Now next, if we go for the next question, we are going to go for the next question, question number 3, that is freezing point. The next question is the freezing point of pure liquid A is T Kelvin. Okay, at some amount of non-electrolyte, non-volatile impurity is added in A, an ideal solution is formed. On cooling at 200 Kelvin, 30% by mass liquid A is present. At 201 Kelvin, 60% by mass of liquid A is present. So at two different temperature, two different mass of A and B, A of two different mass of A, not B, two different mass of A is present at two different temperature. So how we need to proceed it? We need to go for the question with the formula of delta TF equals to I into KF into M. We need to understand the fact that the M value, the molality value is changing. So how we are going to proceed for this question? We are going to find a relation between delta TF1 and molality, that is going to give us delta TF1 equals to KF into molality. Now what is going to be the molality formula, guys? The molality formula is going to be number of moles divided by the total volume of the solution. How are we going to get 0.30? You might ask, sir, where the 0.30 came from? If you remember, at 200 Kelvin, it was 30%. So 30 by 100 is going to be how much? 0.30 multiplied by the total molarity. And if you formulate, the equation is going to be looking like this. That is where this is the delta TF. Here it is the KF and here is the small m. Right? Here is the KF and here is the small m. Now let's go for next. If we are going for this thing, next value, that is at 201 Kelvin, we are going to find that M2 or molality is going to be number of moles of solute divided by 0.60 into M total. That is going to be T minus 201, that is equals to Kf into M. What is M value? Number of moles of solute divided by 60 into M total. Fine. Now we are having equation 1 and equation 2. Equation 1 and equation 2. You are relating the equation 1 and 2. And how you are getting? You are getting a relation that T minus 200 by T minus 201. That is going to give you the value of 2. If you cross multiply T minus 200 equals to 2 into T minus 201, overall the answer is going to come how much? T equals to 202 Kelvin. This is our final answer. Is it clear? Next question, if we go, guys. Next question is asking a mixture weighing 228 gram contain CaCl to an NaCl. If this mixture is dissolved in 10 kg of water and from ideal solution that boil at 100.364 degrees C, the mole percentage of NaCl in the mixture will be. So they're asking at the mole percentage. Again, if you see here, the answers, their values are too much different. 33.3, 66.67, 50% and 75%. So I will suggest you can take approximation, and after approximation, if you find the value is nearby, you can easily conclude that is the answer. For example, if we are taking the formula of delta TB, what is the formula of delta TB? Delta TB equals to KB into M. What is the formula? The formula is delta TB equals to KB into M. Now here, M value is going to be coming as that we are taking I into M value. What is going to come as 0.7 mole? Students, whenever it is I into M, this is not only molality, it is total effective molality. What is the meaning of total effective molality? The total effective molality means you are having the I value of NaCl along with the molality of NaCl added with the I value of CaCl2 multiplied by the M value of CaCl2. So I of NaCl multiplied by the molality of NaCl plus I of CaCl2 multiplied by the molality of CaCl2. That is what we call as total effective molality. You can see I have just equated that, and molality always is accompanied with the total weight of the solvent that has been written down, and you already know that is 10 kg. Once you solve it, you are going to get the equation, that is number of moles of NaCl and going to be 7 mole, and this is the equation, right? From here, students, we can easily understand the fact that if I want to find the terms of CaCl2, I can easily find it, yes or no? I can easily find it that it will be 14, it will be 14, it will be 7 divided by 2. I hope you got it what I'm trying to say. It will be 7 divided by 2 into NaCl, that it will be 7 divided by 2 into NaCl, because it will come down and then we can continue with it, right? So henceforth, we can easily find the number of moles of CaCl2 from here. And as we find out number of moles of CaCl2, I can continue the calculation. That is, I think we have done here. Yes, this is what I was talking. 7 minus 2 into n moles of 2 into n moles of NaCl, it will be NaCl 2 into n moles of NaCl, then divided by 3 through into 2 into number of moles of NaCl and divided by 3. I hope all of you got it. This is going to be my scenario. Now next, if we are trying to find another equation, because we have to compare the two equations, we can find another equation with respect to what? With respect to the total mass. The total mass of the mixture is being told as 228 gram, where the molar mass of NaCl is 58.5 and CaCl2 is 111. If you formulate the equation, you will be getting 228, that is equals to number of moles of NaCl into 58.5, that plus number of moles of CaCl2 into 111. Now, if you put the value of number of moles of CaCl2, that will be going to coming as like this, because just now we have found, and as soon as we are equating it, it is going to equal to 228. Now, if you solve, you will get the number of moles of CaCl2 to be 1.01 mole and number of moles of NaCl to be 1.99 mole. Together, they will be giving you how much mole? 3 mole. Now, the mole percentage, if you want to find, that is number of moles of NaCl divided by number of moles of NaCl plus number of moles of CaCl2, you are going to observe the percentage to be how much? 66.33%. 66.33%. Full stop. Let's go for the question number 5. 6 gram of non-volatile non-electrolytic solute X is present in 1 liter and this solution is isotonic. Again, isotonic means same osmotic pressure with this much volume weight percentage of NaCl solution. Isotonic means they are of equal osmotic pressure, and I think we can take the solution of X. So I can easily find the equation of molarity as well as that is a concentration R and T for the osmotic pressure, that is pi x equals to I into Cx RT. That is, we can easily find out a relation of X. That is, first of all, we'll go for the mass of NaCl, which is going to give me 2.925. Then number of moles of NaCl can also be found, weight by molecular weight of NaCl. As soon as you go for concentration, already I've taken 1 liter, so it is going to be 0.05 molar. From here, you can easily find osmotic pressure, which is going to come as 2.463. Now it's coming what I was talking. That is pi x. Pi x is the x which you are finding, which is already isotonic with NaCl. And there, if you put the equation of NaCl, which value you have already found, you can easily calculate the concentration of X. Once you calculate the concentration of easily, you can calculate the molecular weight of X, which is going to come as how much? Which is going to come as 60 gram per mole. Is it clear? Very easy. I repeat the whole process. First of all, we are going to find out the osmotic pressure of NaCl. After that, I will make it equal to X because X has already been told to be as same. Then easily we can find out the concentration of X. And once you know the concentration of X through the formula of volume and molarity, you can easily find the molecular weight, which is going to come as how much? 60 gram per mole. Are we clear with this? I hope we are. Let's go for next. Sixth question. Sixth question is easy. It is asking us that a set of solution is prepared 180 gram of water. So everyone is having 180 gram. And there are three different ABC are being given with have different molar mass. But everyone's 10 gram has been taken. What will be the moles? Very easy question. So what you have to do, you have to find out the formula mass by molar mass. That is the number of moles. You have to find out the number of moles of A, B, and C. Then check who is having highest, who is having lowest. After that, you just need to write it down. We observe A is greater than B greater than C. Very easy. An alkali solution of potassium mercuric iodide is known as, of course, Nestle's reagent. I think we have studied about Nestle's reagents in our principles of practical chemistry. There we have observed that whenever it is potassium iodide basic solution, whenever it is potassium iodide basic solution, it is being called as, it is being named as what type of solution? It is being named as Nestle's reagent. Now, here comes the question. In case of Nestle's reagent, there is an equation also. There is a formula, or you can say basically a reaction also given in our practical book. That is, what is that equation? The formula is AgCl2 plus 2Ki, giving me how much? Gives me AgI2 plus 2KCl, right? I think all of you have seen this. And again, if you take this AgI2 and along with it, you react it with 2Ki, what you are going to get? You are going to get K2 AgI4. That is our Nestle's reagent, right? So this is our Nestle's reagent and this is our answer, Nestle's reagent. Let's go for question number 8. Question number 8 also seems pretty simple. They are saying that if you have a Kb value of 1.5, Kb equation is 1.5 or 1.5 is the ratio, then what will be the 1:5, not 1.5, it should be 1:5. Then what will be the elevation of boiling? Very simple. The formula is delta Tb equals to Kb into M. You just write down delta Tb formula of A and delta Tb formula of B. Then you easily can calculate, and by cancelling out both the molarities because they are same molarity, and you are going to get the same ratio, that is of the Kb, that is 1:5. Answer is 1:5. Next one, if we go. Question is osmotic pressure of a dilute solution for ionic compound XY in water is 4 times. So guys, we need to understand that XY is an ionic. So XY will have I equals to 2, correct? It is of how much times? 4 times to that of what? 4 times to that of BaCl2. Now what is BaCl2? BaCl2 is having I equals to 3. BaCl2 is having I equals to how much? I equals to 3. So as BaCl2 is having I equals to 3, we can put an equation like this where we will get that the osmotic pressure of XY equals to 4 times of osmotic pressure of BaCl2. Now, BaCl2's osmotic pressure is formula ICRT, where I value is how much? I value is 3. RT gets cancelled out. Concentration of BaCl2 is being given, which was of 4 times of the last one. Henceforth, after putting the value, the concentration is coming as how much? 6 into 10 to the power minus 2 molar. The formula, direct answer is concentration is coming into 6 into 10 to the power minus 2 molar. Next question. A gas is obtained by addition of dilute HCl to a mixture, which turns lead acetate paper black. Directly, the question gives us the answer. There is only one gas among the following 4, which turns lead acetate paper black. That is nothing but H2S. So answer is H2S. Next question, the molar depression constant of a solvent is 4 Kelvin kg per mole. The depression in the freezing point of the solvent is this much. The solution of K2SO4 is, so they are asking that what will be the depression of the freezing point for the solution of K2SO4. Let's see the solution. In case of this reaction, we will just have to find out first of all the I value, which is going to come as 3 because I equals to 2K plus and SO4 2 minus. Then if we put the formula, delta TF is directly going to give us how much? 0.36, which is the total depression of freezing point. I hope it is simple and clear. Question number 12. The oxidation state of iron needs brown ring complex. First of all, students, this is the brown ring complex that has been told over here, where SO4 2 minus will be there, and that's why here will be 2 plus, correct? I think we all know how to calculate the oxidation state part. If Fe is X, H2 is 0, so X plus 1 equals to how much? Equals to plus 2. I hope easily we can calculate X will be how much? X will be how much? X will be plus 1. So answer is how much? Plus 1. Next question. Which of the following 0.06 molar aqueous solution has lowest freezing point? Now, lowest freezing point means we have to talk about delta TF. Now, what is delta TF? Delta TF is depression of freezing point. What is delta TF? Delta TF is depression of freezing point. When your freezing point decreases, I repeat, when your freezing point decreases, there occurs depression. Agreed? So your freezing point is decreasing, and as the freezing point is decreasing, the I value is directly proportional to the freezing point, because delta TF is equals to nothing but what? I into Kf into M. Yes or no? So if I is increasing, delta TF will be also increasing. So delta TF is nothing but depression. So I increases means depression of freezing point increases. Are we clear with this? So if it is clear that I directly influences depression of freezing point, Al2SO4 whole thrice is the one who is giving the maximum I, which is equals to how much? Which is equals to 5. So as the I increases, freezing point depression increases, and henceforth option B is correct. Is it clear? Next question. The reagent NH4Cl and aqueous NH3 precipitates. These are the group reagents, and Al3 plus is the correct answer. Are we clear with this? Al3 plus is the correct answer. Next one. Question number 15. 224 ml of SO2 at 298 Kelvin and 1 atm is passed through 100 ml of 0.1 molar in a weak solution. The non-volatile solute produced is dissolved in 36 gram of water. The lowering of vapor pressure of solution, assuming the solution is dilute, will be X into 10 to the minus 2 ml of AG. What is the value of X? This is the question. So as this question exists, we need to understand the fact that SO2 is reacting with NaOH. When SO2 reacts with NaOH, there are two possibilities. Either Na2SO3 will form or NaHSO3 will form. First, at the beginning, it is NaHSO3 which forms. So henceforth, we find the objective that we need to find the number of moles of SO2. What is the formula? The formula is PV equals to nRT, correct? So N equals to number of moles. So N equals to PV by RT. Here P is 1 atm. Here V is 0.224 liter. Here R is 0.0821 and T is 298. Overall giving me how much? Overall giving me 9.2 millimole. So here we need to get one fact very clear. 9.2 millimole means what? 9.2 millimole means 9.2 into 10 to the power minus 3 mole, which can also be written as 0.0092 mole. Henceforth, we can also write it as 0.01 mole. Now, this is very important. Please get to this fact. 0.0092 mole can be written as 0.01 mole. We will be using it in coming minutes. So as I told you, NaHSO3 can be taken, and which will be dissociated into Na plus and HSO3 minus. And therefore, if you see the formula, it is P naught minus PS divided by P naught equals to I into NaHSO3 divided by H2O plus NaHSO3. So as we know that number of moles of H2 is much more than number of moles of HSO3. So although we could have excluded it, but we are not excluding, we are putting all the values, and as soon as we put all the values, 2 is nothing but I. So as soon as we put all the values, we are going to get the fact very clear, that is delta P, or the lowering of vapor pressure, is equals to the overall thing. Now, what is 24? You will be asking me. 24 is nothing but the pure pressure of H2 that has already been told, and that's why we are, although after all calculation, we are getting 24 into 10 to the minus 2. Henceforth, the answer is becoming 24 as answer. Is it clear? Next question, acidified sodium fusion extract on addition of ferric chloride solution gives lead coloration, which confirms the presence of course, nitrogen and sulfur. Students, when we talk of FeSCN, Fe along with NaCNS, there is presence of CNS minus is there. Always the compound of FeCNS minus forms, which gives you red coloration, which together confirms you the presence of nitrogen and sulfur. That is the red coloration reason. Is it clear? Next question. Next question asks you the fact that if 250 centimeter cube of an aqueous solution containing 0.73 gram of a protein A is isotonic with 1 liter of another aqueous solution containing 1.65 gram of protein B at 298 Kelvin, the ratio of their molecular mass of A and B is. So they are asking what will be the ratio of the molecular mass of A and B in the equation. So what we have to do here, we have to understand that there are two solutions, A and B. So we can easily find out their molecular masses as X and Y. We can assume it, and then we can put out the full relation of their osmotic pressure, that is pi equals to CRT, in which we know the mass given. We are assuming the molecular mass. So mass by molecular mass by volume multiplied by R and T, which will get cancel out, and R and T getting cancel out, giving us the answer. So guys, if you look for it in the solution, we have done the same manner. Let molar mass of protein A be X gram and B be Y gram. The osmotic pressure of protein A is 0.73 divided by X, and this is the volume into RT, and this is the overall thing divided by the volume into RT. Then pi A equals to pi B. As soon as you equate it, you're finding the X equals to Y, which is coming as answer 2. Next question. Gildal method for detection of nitrogen in organic compound cannot be used in the case of. Neither Gildal method can be used for nitro nor a nitrogen in a ring, neither for azo. So answer is all of this. So let's go for next question, question number 19. Question number 19 says that if 0.756 gram, if 0.756 gram of a chloro derivative of organic compound gave this much gram of AgCl, what is the percentage of the chlorine in the compound? Guys, when we look for it, we do find that chlorine percentage in AgCl. How much is the percentage of chlorine in AgCl? That is coming out to be 24.74%. Now the weight of chlorine in AgCl can easily be found out that 24.74 divided by 100 multiplied by 0.287, that is going to give me how much? That is going to give me 0.0710 gram. Now the chlorine in the compound is how much? 0.189 gram. So the overall compound is 0.189 gram and chlorine is 0.0710. We can easily find out the percentage. Weight of the chlorine divided by weight of the whole compound multiplied by 100, going to give me how much? 37.59. Is it there? Let's see. Yes, 37.59 is there. So option D is the correct answer. Question number 20, match the column 1 to column 2. Students, I hope you understand that Lazanis test has directly to do with sodium fusion extract. Followed by, if we talk of Carius method, it has directly to deal with AgNO3. Remains N2 gas and NH2SO4. We all know Gildal method includes H2SO4. So this will be Gildal method, and Dumas method, of course, is the one who has connections with what? Who has connections with N2 gas. So yeah, we end. Are we clear with this? Is it clear? Let's go for next. When 0.15 gram of organic compound was analyzed using Carius method for destination of bromine, 0.2397 of AgBr was obtained. The percentage of bromine in the organic compound, very easy question. So in this question, we easily can go for this, where they are saying that percentage of bromine in the organic compound, that is mass of AgBr divided by the mass of organic compound, multiplied by mass of Br by mass of AgBr into 100. Direct formula we are using, we are putting the values and we are getting the answer to be as how much? We are getting the answer to be 68.01%. Very easy question. So let's go for next. Next question also, I think it is very direct. So next question is 1.46 gram of biopolymer was dissolved in 100 ml of water, exerting ordinary pressure of this much, the molar mass of biopolymer. Very easy question. Pi equals to CRT. C is nothing but the weight divided by the molar molecular mass, and then we are putting all the values and we are easily calculating the molecular mass, that is coming 15.02 × 10⁴ gram per mole. Next question is a big question. It is about Gildal method. Students, in case of Gildal method, we are having few parts that we need to remember. Ammonia reacts with H2SO4, giving you some reactant, some product. We need to be focusing about each and every relation given in Geldal method, because Geldal method is a quite a complex question. So let's start. In the question, first of all, let me read out the brief. The question, they're saying that ammonia evolved is 0.73, which is taking 100 ml of 0.5 molar H2SO4 to get neutralized. They are saying if 0.73 gram of this compound is used for Dumas method, then XML of nitrogen gas comes out. Then XML of what comes out? XML of nitrogen gas comes out. So their question is how much is the nitrogen gas? That's the basic thing. If it is X by 30, we are doing at the end. So let's start our solve. We know that NH3 reacts with H2SO4 to form NH4 whole to SO4, correct? Then 1 mole of H2SO4 neutralizes 2 moles of NH3. Absolutely right. Then moles of H2SO4 is going to give you how much? 0.5 mole per liter into 0.1 liter, that is 0.05 mole of H2SO4 is coming out. Then the moles of NH3 is nothing but 2 into the moles of H2SO4, which is going to give you 0.1 mole. Then the moles of nitrogen or the moles of NH3 is 0.1 mole, same, continued. The moles of nitrogen gas. Now two nitrogen comes together to form nitrogen gas, that is N2 gas. That gas is coming out as 2 moles each, so 0.1 divided by 2, that is 0.05 mole. We know the formula, that is PV equals to nRT. We know the formula, that is PV equals to nRT. And as it is PV equals to nRT, V equals to nRT by P. That is giving us the overall scenario as, PV equals to nRT, and we are putting the formula and everything, etc. We are calculating the pressure. Pressure is coming at 0.8 atm. Pressure is coming as how much? 0.8 atm. This pressure is of whom? This pressure is of nitrogen gas. Is it clear? This pressure of nitrogen gas is coming of 0.8 atm. How we did it? We calculate the mole, then we put the formula, and we got the answer. Now we are substituting the value in case of volume, because pressure is now taken, pressure of N2 has been taken as 0.2 mole. The overall volume is coming out for Dumas method. Now this was up to Geldal method. This was Geldal method, kg I'm writing. Then we used ideal gas to formula, ideal IG we used, ideal gas we used to find out the volume. And after we found the volume, we are just putting or substituting the values to get an idea in Dumas method. The answer is coming 50 ml, because 1500 by 30 gives you 50 ml. Is it clear? So first of all, you started with Geldal method, then you used ideal gas formula after Geldal method, then you're putting the final value for Dumas method, getting the answer as 50 ml. It's quite a big question. So let's go for an easy one. Question number 24. The osmotic pressure exerted by a solution prepared by dissolving 2 grams of protein of molar mass 60 into 200 ml of water. Very easy. Directly formula, pi equals to m by w by m by VRT. You're just putting all the values. You're going to get pi equals to 415 Pascal. Do remember that whenever you are having bar, you are converting it into Pascal, you're multiplying by 10 to the power 5. That's it. Question number 25 is also quite easy. Question number 25 is saying that 2.5 gram of protein containing only glycine is dissolved in water to make 500 ml of solution. The osmotic pressure of the solution at 300 Kelvin is found to be 5.03 into 10⁻³ bar. Total number of glycine units present per protein. So each glycine unit present per protein, they are asking. Pi goes to CRT, you find the concentration. As soon as you find the concentration, you can find the number of moles of protein, because concentration nothing but moles per liter. As soon as you find it, you can easily calculate the molar mass. After you calculate the molar mass of the protein, you can go for the glycine unit, because each glycine unit was weighing 75 grams. So total how many units you have? 330 units you have. Well, how many units you have? 330 units you have. That's it. Now, how to calculate the molar mass of glycine? Easily, we can calculate the molar mass of glycine, because we know the glycine formula, that is nothing but CH2 NH3 COOH. We know the number of carbon. How many carbon are there? 2 carbon are there. C2, how many hydrogens are there? H6 NO2. So you can easily calculate, which is going to come as 75. That's it. Next, question number 26. On complete combustion of 2 grams of organic compound, CO2 and some amount of water. Okay, Lebig's method. That is, you are burning organic compound and getting carbon dioxide. So percentage of carbon is 12 by 44 into mass of CO2 by mass of compound multiplied by 100, going to give you 60%. Lebig's method. Again, question number 27. Question number 27, they're saying that osmotic pressure of blood is this much bar at 300 Kelvin. To inject glucose to a patient intravenously, it has to be isotonic with blood. The concentration of that much thing is. Okay, fine. Let's go for it. So you are finding the concentration C equals to pi by RT. Pi is going to give you how much is given as 7.47 bar. So if you're finding the concentration, that is 7.47 divided by 0.83 into 300 mole per liter, the concentration overall is coming as 0.3 mole per liter. The concentration of glucose you are using, because that is mole per liter of glucose. So 1 mole is having 180 gram. So 0.3 into 180 is going to give you 54 gram per liter. Easy, easy peasy. Next one is very easy questions. Next one is question number 28. The question number 28 is asking you, in KVS method for estimation of halogen, 0.2 gram of organic compound gave 0.188 gram of AgBr. The percentage of bromine in this compound is X into 100 equals to Y. What is Y? So the molar mass of AgBr is of course atomic mass and this, so it is going to give you 188. And as it is giving you 188, so you can easily find out the number of moles. It is coming 0.001. The mass of bromine is going to come as 0.08 gram. The percentage of bromine is going to come as 40%, because 40% is Y. Question number 29, I think it is either Duma or Geldel. Yes, Duma's method it is. An estimation of nitrogen is 0.1840 of an organic compound give 30 ml of nitrogen collected at 287 Kelvin and 58 mm of Hg pressure. Percentage composition of nitrogen. So students, if you find out the total dry, that is P total minus P aqueous, the aqueous tension has to be subtracted. Once the aqueous tension has to be subtracted, you are going to get 744 mm of Hg. After you got it, you have to use the formula P1 V1 by T1 equals to P2 V2 by T2. V2 is going to come P1 V1 T2 divided by T1 into P2. Overall formula, if you put it, V2 is going to come as 28 ml. So the mass of nitrogen is 28 by 22400 ml into V2. That is going to come as 28 into 28 divided by 22400. So overall mass of nitrogen going to come as how much? 0.0356 gram. The percentage of nitrogen is going to come as 0.0356 divided by the total mass of the compound into 100, overall going to come as 19.33%. The percentage of nitrogen is going to come as 19.33%. Question number 21, if we go next, not question 21, we are done with question number, last question we did of nitrogen, the 19.33%. So I think the answer is being given as, yeah, this one we did 14 mm of Hg. Next one 19.33. So next one we are going to go question number, this was 29, this was question number 30. So 30 is going to come 19.33, 30 is going to come 19.33, and then we are going to go for next question, question number 31. Okay, fine, let's start. So guys, in case of question number 30 first, question number 30 I think we have skipped. Yes, in case of question number 30, first 30 we have to, then we are going to 31st. I just got confused over here. Yeah, 30. The osmotic pressure of a solution of NaCl is 0.10 atm, and that of the glucose solution is 0.20 atm. The osmotic pressure of a solution formed by mixing of 1 liter of sodium chloride solution with 2 liter of the glucose solution is X into 10 to the minus 3 atm. What is X? In this question, they are clearly mentioning us that the osmotic pressure of two different things. One is NaCl, one is glucose. What is the difference of NaCl and glucose? NaCl has something I, because Na plus Cl minus, Van der factor is there. Where in case of glucose, there is no Van der factor. So in case of NaCl, 0.1 equals to 2 into concentration of NaCl into RT. And here it is concentration of glucose into RT. Once we are having both of them, we can put the concentration value. And after we put the concentration value, we can easily equate them. And as soon as we equate them, volume total is going to come as 3 liter, because 1 plus 2 liter equals to 3 liter. The concentration of NaCl overall is coming as 0.5 divided by 3 RT, and glucose is coming as 0.4 divided by 3 RT. The total osmotic pressure, once we calculate, one thing we need to keep in mind, every time you are calculating the concentration separately, I has to be considered. Here, I of glucose is 1, so no worries, but I of NaCl is 2. So that's what we have to keep in mind. And as soon as we put the value of that concentration of NaCl into I of glucose is remaining as 1, so it's 0.4 by 3 RT, but here it is becoming 0.2 into 0.05 by 3 RT. So overall, after calculation, you're going to get 0.1666, which is nothing but 1.67 into 10 to the minus 3. So answer of question number 30 is what? 67. 19.7, whereas that the answer of question number 29 was 19.33, right? So here it is 19.33, or you can just write down 19, because overall if you round the round out, it is going to come as 19. Question number 31, if you go, question number 31 is asking you, sorry, we have a mark over here. So let's start. Question number 31. An organic compound contains carbon, hydrogen, and oxygen. Very easy question. So they have given carbon percentage, hydrogen percentage. You just need to find out oxygen percentage. 100 minus carbon plus hydrogen is going to give you oxygen percentage. After you find out each and everyone's percentage, what you can do, you can easily divide that percentage with their molecular mass. Once you divide it with the molecular mass, you are going to get the weight ratio or the empirical formula ratio. And once you got the empirical formula ratio, you need to put the values and you need to take the ratio out of it. So if I do that, that oxygen 100 minus this much, you are going to get oxygen to be the part of oxygen to be 51.62. You have to divide it with the molar mass, and you're going to get 1:3:1, the ratio. So it will be CH3O. Answer will be CH3O, option B. Question number 32. If the elevation of boiling point of 1 mole of glucose is 2 Kelvin, depression of freezing point of 2 mole of glucose is the same of the solvent is 2 Kelvin, the relation between Kb and Kf. In this case, guys, we have to find separate relation of delta Tb and delta Tf. Kb is going to TB is going to give us the Kb value of 2 Kelvin per mole, whereas Tf is going to give us the formula of 1 Kelvin per mole. Now, as soon as we equate them, we will get a relation of Kb equals to 2 into Kf. I repeat, the solve is very easy. Just find out the relation or the equation of delta Tb, find out the equation and relation of delta Tf, equate both of them, and once you equate both of them, you are going to get value Kb equals to 2 Kf. That's it. Question number 33, if we go, question number 33 says in borax bit test match, which of the following compound is formed? Easily we know metabolite is formed. In this case, metabolite has the formula NaBO2. That is our answer. Question number 34, if we go, 34 is also a direct question. 34 asks us that a solution prepared by dissolving 0.6 gram of urea and 1.8 gram of glucose, molar mass has been given is 100 ml of water, the osmotic pressure of the solution. Very easy thing. So you have urea, you have glucose, you're dissolving both of them, the total number of moles you are getting. After you get the total number of moles, you know the volume. After you know the volume, you can find the concentration. Once you find the concentration, you know the temperature, put the formula, and pi is equals to 4.92 atm. Next question, which of the following is correct statement? Copper can undergo disproportionation. This should be copper plus, printing error, it will be cleared before your exam. So here it is copper plus can undergo disproportionate reaction aqueous solution. Definitely copper plus can become copper 2 plus and copper. So yes, it can undergo. Copper 2 plus is more stable than copper plus. Of course, more the positive charge, more the charge density, better the enthalpy of hydration, better is the stability. Hydration energy of copper 2 plus is more negative than copper. Yes, that is also true. Because in case of copper 2 plus, more amount of water is getting satisfied due to the high amount of charge. So it is more negative than copper. And henceforth, all the statements are correct. Question number 35, all the statements are correct. Let's go for question number 36. A solution containing 62 gram ethylene glycol in 250 gram water cooled to minus 10 degrees C. If K for water is this much amount of water separated as ice. Very easy question. Guys, here we need to find out the depression of freezing point, which is going to come as 10 Kelvin. Then you have to just find out the molality. The molality is going to come as 5.376 mole per kg. Molecular mass of ethylene glycol, if this is the structure, you can easily find the molecular mass. Then molality has the formula moles of solute divided by the mass of solvent. Moles of solute has already been calculated and can easily be calculated as we know the molality formula. Then molality is also given as 5.3. If you put the values, it's going to come as 0.186 Kelvin. The mass of liquid water is basically 100 gram per kg. So 1000 gram per kg, we are putting the value and we are getting 186 gram. Followed by, they are asking what will be the mass of the ice. So mass of the ice will be initial mass of water divided minus final mass of water. 250 minus 186, that is going to come as 64. So what is the final mass of ice? That is 64 gram. I hope it is pretty clear, because here what we did, we calculated the ethylene glycol. Then after calculating the molecular mass of ethylene glycol, then we just use the formula molality, where it is the moles of solute divided with the mass of solvent. We have to find out the mass of solvent after everything happened, depression and all happened. So we found out the mass of the solvent is is actually 186 kg, 0.186 kg or 186 gram. And we already knew the mass of water before the reaction. So 250 minus 186 is going to give me 64 gram. That is my answer. So let's go for next. They are given some reaction and they are asking us about the coloration part. If you see the reactions, this is also principle for practical chemistry. When you react NH4OH with Fe3 plus, you get FeOH whole thrice. On reacting with HCl, you get FeCl3. On reacting with K4FeCN6, you get Fe4 FeCN6. And finally, when you react it with KCNS, you get FeSCN whole thrice. So this is your final compound. Then they have given some comments. First of all, let us mark ABCD. So AB, this is C, and this is last one is D. They are saying that in the question, they are saying that what is the question? Yeah, A is formed is reddish brown precipitate. Now here they are asking incorrect statement. One thing we have to keep it in mind, they are asking about incorrect statement on the correct statement. As they are asking about incorrect statement, we have to understand that first one, it is giving reddish brown precipitate. Yes, first one gives you reddish brown precipitate. C has blue in color. What is C? Let us see what is C. Oh yeah, definitely. It is Prussian blue in color. It is Prussian blue in color. We have studied about this compound specifically, that this gives you what color? This gives you Prussian blue as color. Okay, wait 1 second. This is giving you what? This is giving you Prussian blue as color. So as it is giving you Prussian blue as color, 1 second. Yes, where the question came. Yes, here is the question. So it is giving you what color? The compound A, that is giving you what color is that? Yes. So yeah, let's go for it. Yeah. So we are finding that this one is giving you what color? This one is going to give you Prussian blue color. Prussian blue color. So definitely the option A is correct. Option C is correct. Now compound D is blood red in color. D is blood red in color. No, CNS minus is blood red in color, not this one. So this one is not blood red in color. So it is not correct statement. So answer is option C. Then B is insoluble in water. B was FeCl3 and FeCl3 is insoluble in water. So B is also correct. So option C is the correct option because it is incorrect statement. Question number 38. The depression of freezing point observed for a formic acid solution, formic acid HCOOH, is this much. The density of the formic acid is this much. The Van't factor of the formic acid is nearly. Fine, let's go for it. Second last question we are now dealing with, that is formic acid is having 0.5 ml per liter. Now the mass of this is easily be calculated with from the density, moles into density is going to come as 0.525. Then the molar mass is 46.03. The molar mass of HCOH is being given, so the moles can also be found. It is 0.01141. The molality is how much divided by 1 kg is going to give you 0.1141 molal. So Van't factor, actually the formula is delta TF equals to I into KF into M. Now if I want to find out I can be written as delta TF by KF into M. So if I put all the value, I get 1.908, which is near about 2. And let us see the options. This 2 is being given, no, 1.9 is given, so correct answer is 1.9. Let's come for question number 39. Question number 39 is saying that you have two compounds C and D, which gives C gives both steric ammonium nitrate. So both of them are alcohol, both of them. Yes. Now they are saying that as both of them are alcohol, they are saying that iodoform test, one gives positive, one gives negative. I think we all know what is the positive iodoform means. There is a alpha methyl group. Lucas test, it gives after 5 minutes, means it's a secondary alcohol. And this one is a tertiary alcohol, correct? Because it gives immediately. So let's see the options. In the options, D is tertiary alcohol for option B and C. So either B or C is the answer. Now option B is having primary alcohol, option C is having secondary. We just now said it is secondary alcohol and it should also have alpha methyl. It has an alpha methyl group. So yes, option C is the correct answer. Last question, when a certain amount of solid A is dissolved in 100 gram of water at 25 degrees C to make a dilute solution, the vapor pressure of the solution is reduced to 1. Okay. The vapor pressure of the pure water is this much, the number of moles of solute added. Very easy question. According to RLVP, we know the P naught pure minus P solution minus P naught or P solution. Sometimes we say both. When we take P solution when we don't consider solute minus solvent. If we put that formula, P solution has been told as to be P naught by 2. If we put all the values and we have approximated that solvent is much more than solute, that's why we have taken a P solution. And if we go for the relation and put the values, we are going to get 5.55 mole coming as the answer, because here it will be P naught minus 2. So P naught by 2, P naught by 2, whole thing will get cancelled out. It will go there. So 1000 by 18 is going to come, 1000 by 18 is 5.55 mole. So correct answer for the last is 5.55. So thank you, everyone. We end our meeting over here. Any doubt you have, please approach, and all the best for your other exams. Thank you.